Hi, good evening. My name is Kate. And I'm a PhD student in the computer vision visual historical record, which captures all of these nuances as well as these everyday things that we might not write down. And these images are complementary to textual historical documents. So one view of history is that it's the study of finding patterns in events and in trends from large amounts of data. And for written history, historians are pretty comfortable using what's called natural language processing to mine large text corpuses. So this is some examples using Google Books, which is the online collection of every public domain book. And what we can do is we can analyze word frequencies. So for example, during the American Civil War here, we can look at how terms the North, the South, and the enemy have been used before, during, and after the Civil War. On the upper right, we can see how the frequency of the word influenza in text documents spikes according to influenza outbreaks in different countries. We can also see the progress of science, and so we can see the emergence of ideas such as evolution in blue and DNA in teal. And we can also look at how gender roles and the views of women have changed in the past 200 years, where we see that the frequency of the word woman is now just about the same as the frequency of and it's really interesting. We can actually see the dip in glasses wearing when the contact lens is introduced, and we see it dip again when the daily disposable contact lens is introduced. We can also see that men tend to wear glasses more than women in general. So in addition to tracking these trends, we can also mine for date-specific patterns. So things that made a certain era look like that era. Because, as you know, not everyone in the 60s looked the same. There's multiple modes in people's appearances. So this is a great piece of art from Hans Egelblum, where he kind of captures how people in a certain place at a certain time all tend to dress the same, but there's these multiple modes or multiple trends happening at the same time. So we apply a technique called discriminative clustering, which basically allows us to automatically answer the question, what makes a decade look like that decade? And so this visualization, on the left, we're showing the average image from each cluster, and on the right are the top images that exemplify that trend. So for example, in the 60s, we have like the winged flip, we have the bob, we have the 60s glasses, and in the 1970s, we can see afros and bouffants. And this here's a visualization of all the decades. And so again, let's see, I think the 2000s are also nice. You can see the prevalence of completely straight hair. Also in the 70s, you can see that, and the curly updos of the 1980s.
And thinner faces, much thinner in the 2000s and the 1930s.
It does. I wonder if that is because of their hairstyle, if it's
I don't
an
think so.
illusion, or
No.
it would be an interesting question to figure out. Okay, so now that we can see that there are patterns that appear in different decades, we're wondering if these patterns are enough for the computer to be able to guess when a picture was taken. So we call this the portrait dating problem. And in this presentation, we'll focus on women because they have kind of more distinctive appearances, but we also applied this technique to men. So try it. Take a guess at what you think the decade is of each of these photos. Any guesses for the left one?
2010.
60, the left one.
80s. Early 60s.
60s, I would say.
Really?
Yep, 1960s because of the wing flip. How about the middle one?
1930s.
40s.
40s, yeah. I personally think 30s and 40s look very similar, so. And then how about the one on the right?
So,
Late 70s, early 80s.
Yep, that curly hair 80s. So we're pretty good at this. So kind of wonder, what cues are we using, and can the computer kind of figure this out also? So we used a modern computer vision technique to basically train a model to predict the date that a portrait was taken, and these are our results. So our model the error of our model is about 4 years. So that means that our prediction could be 4 years earlier, 4 years later than the true prediction. But keep in mind that this is an 85-year, the span of the problem is 85 years. So 4 years is not bad. And this is what we call a confusion matrix, where basically if you're on the diagonal, that means you've made the correct prediction, and if you're off the diagonal, that means you're off. So if you have a lot of points up here, that would mean you're really far off. But we can see that our points are clustered close to the diagonal, so that means that when we're making errors, we're pretty close to the correct year. We're just off by a few years. So to see if what we've learned from this yearbook data can transfer to other image data sets, we collected a small data set of celebrity photos, and we take the algorithm that we trained on the yearbooks and apply it to the celebrity photos to see if it generalizes. So there is a bit of a shift here. The celebrities are older, and they have very glamorous hairstyles as compared to the average high school student. But our model does all right. So our median error is about 9 years. So not as good as the yearbooks, but we're getting some signal. And some of our individual predictions are quite good. So in this plot, the ground truth year is in red, and the prediction that we make, we produce